Hello, everyone. Welcome to PTV Visum Model Application Training with the FDOT District 3 Northwest Florida Regional Planning Model. Today is going to be our first day of the training, and this training is going to be continuing on until tomorrow. My name is Jongsun Won with PTV America, and I'm going to be the moderator for today's session. And I'm with Levi Button and Chetan Joshi and Binny Paul, who is going to be leading the training for, today's training. Next slide, please. All right, before we start, we wanted to give you a heads up on some of the other available resources that you can access to. That could be one of those things that you're seeing here, which is Technical Resource Hub that our team has created. And in there, you're going to be able to see various subsections where you can take advantage of. First one is PTV Talks, which we've been offering over the past 2 years bi-weekly and covering various types of topics. And that webinars all being recorded and made available to you, and you can have full access to that if you go into that PTV Talks section. If you would like to take advantage of self-learning materials, you can click on Ptv Academy, and you're going to be able to see more detailed materials that you can use to learn more about our software. If you would like to get more information on support items, you can go to Ptv Support. And also, we've been hosting users group meeting over the past 22 years. Also, what that means is that we have a lot of those presentation materials that we have. All those are being archived, and you can access to those if you go to Ptv User Group tab. And all those this technical resource hub page could be accessed by clicking on http ptv.to/learn. Then it will take you to that page that you're seeing on the screen now. As a part of those, as I mentioned, Ptv Academy will give you an opportunity to go through the detailed step-by-step instructions on how to use the software. And this is a part of it. We have offered various types of courses, especially for FDOT and the users in Florida. A part of that was Visum, getting to know Visum, getting to know Visum, and Vistro trainings, as well as some other tooltips webinars. So all those could be accessed by you from that Ptv Academy field. It does not require any logins and all that. So feel free to share this with your colleagues or any of those your team members. So one of the parts that we have added to that particular resource hub is the page where we are storing all those Florida models that we're converting to Visum. So you can have access to some statewide models and district models, and we will post it as it becomes available. So at the moment, you're going to see NWFRPM training materials that we've got from the training that we have offered back in last November. You're going to be able to watch 2 days worth of training sessions from there, and also you can download the example files that we have used to go through. And also the presentation slide deck that we have, that Levi has created, and provided, that could be accessed from there as well. And as you may know, PTV offers two different types of software where you could be using it for various types of resolution level modeling. First of all, Visum serves its original purpose is macro modeling, demand forecasting, which we're going to go through today. And then in addition to that macro modeling, Visum is also capable of having you to run the mesoscopic simulation by within the Visum itself, and all the data that you're entering to Visum could be pushed out or exported to Visum for further micro level or hybrid meso micro level simulation studies as well. So don't forget to check out not only Visum but also Visum so that you can take advantage of the full suite of software that we offer. And now with that, I'll pass it over to Levi. And Levi, Stage is yours.
Thank you, Jonathan. Welcome, everybody. I'm just going to go over the quick agenda for today and tomorrow. So for today, we're going to talk about software overview, getting to know Visum, as well as model setup. So what that will entail is what goes into the Visum file structures, what kind of inputs, outputs do we need, what does the interface look like, and then talking a little bit about scenario management. How do you manage various scenarios within Visum? We're going to intermix some Q&A sessions in the middle and at the end as well. We also have a chat box if you would like to submit some questions ahead of time for the Q&A. If it's a simple question, we'll probably try and get back to you right away. Jongsun and Chaitan will be in the chat responding to questions. If it's a better question for the whole group to hear, then we'll save it probably for the Q&A. Tomorrow we're going to be talking about different alternative builds and more about scenario analysis. So we're going to be exploring how to make network updates and apply those updates to various scenarios, how to make various land use updates, and then talk about how to make public transit updates with regard to new public transit lines and new public transit stops. And then we'll finish off the course with model review. So if you're a reviewer or somebody who is project manager, how would you look at the various scenarios, compare the analysis results, and see what major changes have come in the course of your modeling projects? So a little bit more detail today. This timeline is a little bit flexible. We might go a little bit faster, we might go a little bit slower, just depends on how well the Q&As go. We're going to start with talking about the file structure and interface overview, and then talk about the base model inputs and structure. And then we'll take a break, which will act also as, that break time will also act as our first Q&A session. And then we'll get into the scenario management section, and we'll start talking about applying different scenarios. How do we manage our various scenarios? And then we'll finish off with a final Q&A at the end of the day. And then tomorrow we'll look at, again, building a network build, a land use build, do a Q&A, then public transit update and reviewing scenarios, and then a final Q&A at the end. Okay, so the first thing we want to start with is, what will the file look like when you download the NWFRPM zip file? And so when you download this file and you unzip it, you're going to see in there two version files. We have the existing 2015 model file, base model file. We also have a 2045 forecast model file. And then there will be a few different other supporting files that we're going to be talking about throughout the course of today. The key files that you're going to want to look at are the extensions .ver, which is our version file. These are the main files that are read by Visum. And they contain all of the infrastructure and all of the data. It's all self-contained within that .version file. You'll also find our 2045 scenario version file. Again, you can have multiple version files within the same folder. That is totally fine. Some other supporting files that we'll have are list layout files. This doesn't have anything to do with the calibration or operation of your model. This is more of just a view file that will help you organize your data. So if there's a certain layout of a list that you like, certain attributes that you like to see, you can save it as a list layout file. We also have a number of scripts in our model that help with the population synthesis and trip generation and trip distribution. So you'll need these script files to be contained near your, in the same project directory as your version file. But we have these scripts in here. You can go in, they're all Python scripts, so you can go in and look at all of the code of those Python scripts. We also have different graphic parameter files. These are kind of like the list layout files, but they're for any of the graphic settings that you might have. So if you like to have certain heat maps or if you like to display certain graphic feedback, such as link bars or select link or flow bundle or anything like that, those graphic parameter settings will be saved in your GPA files. And so we have a few pre-built here for your use, including some training ones that we'll be using over the course of the next couple of days. Another type of file that we have are filter files. Filter files allow us to filter out certain objects to make our analysis of the network a little bit easier and our operation of the network a little bit more clean. So if you're looking at a certain section of the network, a certain region within the larger model, you can filter out all of the nodes and links and objects that you don't want to analyze, and that'll make your lists a little bit smaller. It'll make it a little bit easier to model if you are filtering by certain attributes or by region or something like that. So for example, you could filter out all nodes that are not signalized, and then you could adjust all of your signalized nodes at the same time. So filter files allow us to use to do something like that. We have some other data formats that you might see as you progress through your models that aren't necessarily in this particular file folder here, such as data exchange formats, .NET files, transfer files, .tra files, and demand structure files. Again, these might be in other models. We see a couple of these in the D1 model, but not in the D3 model right now. Some third-party files that we might be seeing are shape files, OpenStreetMap files, general transit feed files. These are all third-party data sources that we can bring into Visum that will often be found in the same file location. So these are, in addition to the PTV file types, these are additional file types that you'll frequently see with Visum files. And then also databases, we can link to Microsoft Access as well as SQLite. All right, so with that, I just want to quickly, before I move on to opening our first file, I just want to show you what it will look like here. So when you download the .zip file, you're going to get all of these, and we're going to be looking at, we have our 2015 file extension here. We also have our 2045 forecast model here. We've put Visum 2022 on the end of it just to indicate which version these were built in, so you can see what the last save version was. But we're going to be opening up this 2015 Visum 2022 model right here. As soon as I can get this off my screen. There we go. All right, so what I first want to do is I want to walk us through what the interface would look like when you open up your base network. So when you first open it up, it's going to look something like this. You're going to open it up and it's going to have various panels and toolbars and things like that. But we're going to first talk through some of the key features that we're going to see. So when you get to your file, if you right click on the file, you can have various versions of Visum installed on your computer simultaneously. It's not one or the other, you can have different versions on your computer at the same time. So if you have specific versions you want to open your file with, you just right click on the version file and say open with, and you can select different versions of Visum. In this case, we want to open it with Visum 2022. So it'll read the version in, it'll load in all of the file objects, and then you should get something that looks similar to this. And so let's talk through the various interface elements. Okay, so the first element is going to be the menus. So at the top of your interface, you're going to see a bunch of different menus that we're going to be using. For our purposes, we're going to talk through some of these, and we're going to talk through some of the elements in each menu, but we're not going to necessarily go to each menu in great detail. We'll kind of circle back to some of these as we go through the training today. So we're just going to hit the big ones that are frequent stops for users. Then we're going to come through and we're going to talk about some of the toolbars. We have various quick access buttons up here, as well as different ways to save and open different file types, such as filter files or layout files or graphic parameter files, as well as other version files. In Visum, everything is in the window is paneled, so you can desync your panels from each other. You can kind of format the view however you want. If you're working on multiple monitors, for example, you could detach lists or menus, so that way your visual screen doesn't get all cluttered. All right, so to start, let's go back and talk about some of those menus in more detail. So in the file menu, this is your typical Windows operating system style file menu where you're going to have your opens, your saves. We also have options to transfer networks and scenarios between each other. You also have access to the Scenario Manager tool if you're going to be using the Scenario Manager tool. You can also import and export various types of data from this model. So this is where you would import your shape files and things like that. You can also set your project directories. This is one that people often forget about, but that can be very useful. So if you have certain files that you're accessing that are in a different location than the version file, maybe you have some data files or some scripts that you're running that happen to be in a different directory, you can go into set project directories and configure your model so that it runs more cleanly, so you don't have to drop everything into the same folder. Open files, save files, transfer network and scenarios. You can import your data, export, set directories. Okay. Next, we want to talk about are the edit and the view menus. The big one in the edit menu is going to be the user preferences. So this is where you can go through and configure your hardware and interface specifications, configure your drivers, things like that. And then in the view menu, this is where we can open and close some of those panels that we saw before. If you accidentally close one of the panels, you can come into the view menu and reopen it. For example, the network editor, you can go in and reopen that network editor. The next one we're going to talk about is the list menu. Now, every object within Visum has, every physical object has a list, and some of the background objects have lists as well. So instead of just looking at it graphically, you can look at it in an Excel kind of style table where you can get different columns representing each of the attributes, as well as the rows representing the actual objects.
Attribute tables in Esri.
Okay.
So,
yeah, it's kind of like the attribute tables that you'd have in Esri. Thank you, Chetan. So yeah, again, the way the lists are laid out are you'd have different types of attributes in the columns and then the actual object numbers in the rows. So this gives you a capability to mass edit your objects pretty quickly from these list menus. And we'll take a deeper look at those in a couple of minutes. Next, we're going to look into the calculate menu. The calculate menu, this is generally where you're going to define underlying methodologies. So things like how is impedance calculated for turns and links and nodes and things like that. You can also execute the procedure sequence. We're going to circle back to the procedure sequence, but basically this is where you can automate a bunch of the calculations that you might do in your model. For example, we have the procedure sequence. Here in the procedure that we're going to look at in our model today, in the D3 model, we're going to be looking at trip generation, trip distribution. We also have assignment and some analysis that we're doing. And so instead of manually creating all of our matrices and things like that, we're going to be going through and automating this process using these procedure sequences. In the general procedure settings, this is where, again, as I mentioned, we can define built-in impedance and delay functions. You can also use our API menu to create your own impedance functions if you so wish. And again, this is in the calculate menu. Sorry, just one sec. For some reason, my PowerPoint is not moving. There it goes. All right. The next list that we're going to talk about, just again as a brief overview, is the graphics menu. If you recall back a couple slides, we talked about graphic parameter files. This is where you can configure what your interface looks like. So you can configure different attributes to be displayed on different objects. So for example, if you wanted to look at link volumes, you could create link bars in the graphic parameters menu. We're going to walk through how to do some of these graphic displays a little bit later in the training sessions. Especially tomorrow, we'll be talking about flow bundles and select link capabilities as well. This is what it looks like if you hit Control G, or if you enter in the graphics parameters menu. You can see that each of the objects that we have in the network has their own graphic parameter settings. So you can kind of think of them as different layers, and then you can configure what those layers look like in the Zoom independently of each other. Whether they're active, whether they're inactive in terms of visually, what attributes are displayed. If you want to add labels to them, you can add labels to them. You can have dynamic feedback where the graphic parameters change based on certain attribute types as well, such as level of service or control type at a node or something like that. And then down below, we can visualize various assignment results. So this helps us with troubleshooting, as well as checking connectivity of the network, and as well as seeing things like select links. So if we drop down a flow bundle, we can see where are all those trips across that bridge coming from and going to. And that really helps with analyzing, okay, if we have too much volume on a particular link, where's that volume coming from? Which zones are they coming from, and which zones are they going to? All right, next is the network properties menu. This provides access to all sorts of settings that we have in the background, as well as some of the non-physical object types. So for example, if you were to put in public transit lines, this is where you define the operators and the line blocking versions and things like that, as well as delays and fares and fare zones for those public transit objects. You can also define user-defined attributes in this list menu as well. So if we get into the network settings, this is where we can define things like the units and the direction of traffic. So you know, in the States, mostly we're right-hand traffic and we're using imperial, but you could always switch between these values ahead of time. You can also use various projection systems within the model. When we get into the Zoom, we'll see that there's going to be embedded background maps using Bing or OpenStreetMaps that allow us to build anywhere in the world. And because of that, we need a good projection system so that we have accurate scaling of our model. And so you can pick between a variety of different projection system types. A big one that people like to use now are user-defined attributes. So if there are attributes that certain outputs or certain inputs that you need to use as part of your local region or as part of this specific project, you can go in and create user-defined attributes and use these attributes to store data or analyze the network in some unique way. This includes attributes that are either just basic input attributes that store a single piece of data, or they can be formula-based attributes where you can go in and type in custom calculations for things like emissions or something like that if you wanted to create custom formulas on certain turns or links or something. Then we have these network properties as well. These are all background properties to the physical objects that you'd put into the network. So things like signal controllers and public transit fares and coordination groups. A good example is our public transit operator. We're going to look at this in our public transit example that we're going to do tomorrow. So right now in the existing model, we have Star Metro and FSU as transit operators. And with the transit operators, they're going to have their own stops and their own lines that they're going to be servicing. But this transit operator indicates things like fare prices and stuff like that. The next menu that we're going to talk about is the demand menu. Again, all of this is just going to be this is just as of right now a brief overview. We're going to come back through these menus in greater detail with specific examples as we go through this training. I just kind of want to give you a brief overview to start. The demand menu is where we go to configure the different demand strata, demand models, and methods used in the assignment. So if you're running a 4-step assignment or something like that, or if you want to define different modes of transportation beyond just cars and trucks and public transit. So this is where you'd go to define all of that data. So what we're going to look at are the different modes that are in the model. As we go through, we have kiss and ride, park and ride, single occupant vehicles, trucks, light trucks, heavy trucks, and they're all combined into different demand segments. So SOV or HOV or off-peak transit or peak transit. And these demand segments group together different modes for various uses and different classifications of modes for different uses on links. So for example, if you have an HOV link or an SOV link or a transit-only link. Those modes are then combined together with various time series. In this model, it's a single day model, but you can have, if you look back at the D1 model, it has AM, PM, midday, and nighttime. This one is just a 24-hour model, so it only has one time series, but you can combine different demand strata into your different demand segments into different time series. And then we have the script menu. This is where you can write all kinds of custom scripts. You can do custom imports, things like that from the script menu. For example, this is where if you look at some of the Visum add-ins, we have custom importers that were written for TransCAD, DivaGeo, and we have the Cube Network import as well. We also have this Python console. So if you're actually writing some of the scripts for future models or editing some of the scripts, you can use this Python console. It gives us a link to a PyCrust where you can test out your various modules or script elements to really help with debugging, so you don't have to write a whole script and then hope it runs at the end of the day. And then finally, one of my favorite menus is the help menu. I often do tech support and training and third-party support as well. And so this is where you can go and get access to technical support as well as technical manuals. In the example files directory, we have all kinds of examples for various uses and use cases and things like that. So I'd really recommend going and checking this out. If you go to the Visum help, this is a really useful online tool where you can look up different attributes and descriptions and definitions of functions and things like that. We have a link to the actual user manual as well as COM help. So if you're doing a lot of scripting or custom programming, we have all kinds of help tools for COM. And then our online FAQ and technical support is always accessed there. As a quick update to our tech support, there's now a tech support portal where you can go and track all of your tech support tickets and see the status on your ticket, as well as see what cases you've previously had and what their resolutions were. So you kind of have a whole history of questions that have been asked, as well as links to FAQs and other things like that. Okay. So we're going to get into now opening up the model, and we're going to go through the interface of the model and just kind of get used to what does it look like to open up a Visum model and get inside of it and start working. So if you haven't done so already, Johnson posted a link to a PTV box download where you can download the zip file for the model, and it should have all of these supporting files in there. So what I'm going to do is I'm going to give everybody a couple of minutes to quickly download that zip file if you haven't done so already, and unzip the zip file. And then if you have access to Visum, let's pop open the 2015 base model that we have. So I'll give you about 2 or 3 minutes or so, and then we'll go ahead and proceed on to the next little stage. In the meantime, if you have any questions so far, don't hesitate to put them into the chat or anything like that so that we can respond to those. Okay, so I'm going to open up my version as well. So it's going to look something like this. I'm going to use this, right click, and I'll say open with Visum 2022. And this is what you should see when you first open the Visum file. All right, so in this view, we have a few different panels that we're going to talk through. But real quick, just to kind of review the various menus and things so you can kind of see it from the model perspective. When you first open Visum, you can click on the File menu, and here we have access to all of our different actions from the File menu, including things like opening various files. You can open external matrices, you can open graphic parameter files, and project directories. Here we have the save file as, so you can save your file, you can also save graphic parameter settings, things like that. Here we have our compare and transfer networks. We're going to be using this later today to talk about if you have different version files, how do you compare them to each other. We have a scenario manager tool. I'm going to talk a little bit about this in this course. We went into great detail in the D1 course, and we wanted to have a mixture of the two methods, either having various version files or having all of your scenarios in one file using the scenario manager tool. So we have a scenario manager tool there. We also have various imports. Here's what all of our importers look like. Here's what all of our exporters look like. So you can export to Mass Modeler, you can export to Visum. We've also added a Visum export based on coordinate-based routes. So basically what that will do is your node IDs and things don't have to match up perfectly between Visum and Visum anymore. You can just export the routes and the volumes, and that it'll kind of match to your Visum model. And so it makes that export process a little bit easier. We also have links to previously used Visum models down below. If we go over to the list menu, we can see all of the different types of objects that we have in the network, as well as OD demand. We have private transportation, public transportation. All of these lists have various attributes associated with those specific objects. The calculate menu, this is where we can open up our procedure sequence. So if you're interested in what the procedure sequence looks like, you can go calculate procedure sequence, and you can see what all of the automated procedures are in the menu there. Our graphic parameters menu, here's our network objects menu. So you can go through here and you can look at all of those background objects, as well as our network settings. Sorry, this opens up a separate panel that we can look at over here, where we have our imperial units, our right-hand traffic units. And if you click on the tab that says coordinate system, you can look at our different projection systems that we have within the model. So there's quite a few to choose from with different coordinate systems. And then again, my favorite menu, the help menu. You can have links to our online helps, as well as I wanted to show you the examples. So if you're curious, you can go to examples. Here we have first steps tutorials. So this will kind of walk you through a sample project as well. Or sorry, that's our quick start tutorial. Then we have first steps, kind of a quick checklist of what to do there. And then in our examples and quick start directory, we have different use case examples that you can go look at, and each one has a PDF walkthrough as well. Okay, so to get started on the interface itself, there are a few different panels that we're going to talk about and walk through in our network. The first panel I want to look at is our network objects panel. And so each one of these panels, if you hover your cursor on the boundary, you can make them wider, or you can make them longer, or if you grab the header of the panel, you can actually detach it from the network. Let's go ahead and take a couple minutes to kind of get used to, or take a minute or two to get used to the to manipulating the interface. Some panels can be stacked on top of each other. For example, if we look under the network editor, they're stacked on top of each other, so you can click on the tabs down below to look between those different stacks. But if you want to detach these stacks, you just left click on one and drag it off of the stack, and now you can detach this panel. So for example, I can take my procedure sequence and I can put it on my other window frame if I wanted to do that. Or if I drag it back onto the network editor, I left click where it says, where you see this bar at the top, I left click and drag it. You can see how I have now a little icon that I can put it into different locations on the network editor. This can be really helpful for kind of organizing your data in ways that you like. For example, if we open up one of the lists for just anything, I'm just going to open up, for example, a nodes list. It's going to open up a list that's stacked, but maybe you want to have your nodes list off to the side or something like that. So we can detach it, and I can put my nodes list attached to the side of my network editor. So that way I can see both my network editor and my nodes list at the same time. If you don't want a particular panel anymore, you can just click the little X and that will close that particular panel. So again, take a minute or two, get used to the interface with adjusting the different windows and things like that. For now, I'm going to shrink down my quick view panel. We're going to come back to that quick view a little bit later. I just want to see more of my network objects all at once. So within this network objects panel, this shows the different physical objects that are in our network. Again, within the network menu, you can see some of those background objects that we can edit there. But the physical network objects are the ones that we're actually seeing in our network editor. So in this case, any object that has their icon lit up with like a little white square, in this case, links, for example, is turned on. So we can see all of the links in our network editor. I can turn off the links by clicking that white box. So now my links disappear, and I can turn on nodes. So if I click that white box, now all the nodes in the network turn on. So in this case, you can quickly go through and look at various objects. If I zoom in, for example, on the Tallahassee region, in order to zoom in on your network editor, you'll hover your cursor over wherever you want to zoom in, and you'll just use your scroll wheel to, you push up on the scroll wheel to zoom in, you'll pull back on your scroll wheel to zoom out. You can also use some of these tools at the top of your network editor to zoom to different levels. What is the tab? Sorry, I got a question. What is the tab dock next to the quick view? Oh, the quick notes or the marking tab?
Extended network objects. Maybe you can check a node, click a node and show the extended markings, integrated data structure.
Sorry, I got a question in the tab that says, what is the window next to the dock view? This will let you click on specific object and see extended markings, so you can see additional information about that object and see what is all connected to that object. Additional markings. The quick view also gives you quick access to that particular object. Yeah, so it's a fully integrated database. So in this case, anytime you click on an object, they're all connected to each other. So in that case, you can see all the links that are coming in and coming out of a node if you were to click on it, or onto a particular, if I clicked on a link, for example, my marking tab would show me all the nodes and turns coming in and out of that node. So this way we can store true shape networks without having to without the runtime overhead and things like that. So since everything is all integrated, this window allows us to quickly access what objects are linked to it. So for example, if you have you're looking at turn counts and you're wondering, okay, which link are they coming from? You can click on a node and see what the link number is that is assigned to that node. Depending on what object you have selected up above, so for example, if I have links and nodes turned on at the same time in my network, if I have the links object selected, that allows me to only select links. Whereas if I have nodes selected, that allows me to go through and select various nodes in the network. What this helps us do is kind of organize our data so it doesn't get too cluttered, and so you're not trying to click on a link when you mean to click on a node or anything like that. All right, so since we're zoomed out, if we have the whole network active, it can be kind of hard to see what's going on. So what I'm going to do is I'm going to take my little zoom box tool right here, this little plus with the box around it. And what I want to do is I want to zoom in on one of the major metropolitan areas. We have Tallahassee, we have Pensacola, so I'm just going to zoom in on the Pensacola area just because it's in the center of the screen. So we can kind of zoom in, and we can zoom in again on the downtown region to kind of see what is going on more at kind of like a more micro scale, and see all of the details of the network that we have in here. And so, for example, if we zoom in on the Pensacola area and we activate our nodes, you can see how many nodes are actually in the network. Because when we zoom out, it kind of picks out the higher tier nodes to display. But as you zoom in, it'll display more and more of the nodes within the network. So, for example, I can zoom in pretty close to an area, and then activate my nodes and see, okay, here are all the active nodes in the network that we have currently. These white lines, what you're seeing are the links themselves. And if you look on the right side, the links are actually being displayed with some of the analysis results. So this model has already been run, and the assignment has already been completed. And so what we can do is we can see, based on the link bar width, what the assigned volume is to each link. And we can see, based on the darkness of the color, what is the volume to capacity ratio. So we have, lighter colors, you're closer to your 100%. Darker colors, you're closer to 0%. And so this really feeds us a lot of good information just by looking at it from the top down. All right. If you want to pan around on your network editor, there's two ways to do it. There's a little hand button that you can click on, and then that will let you left click and drag, and you can move around on your network editor. Another way to do it is, if you do not want to click that hand button, you can also press down and hold your scroll wheel, and that is the hotkey for panning. So if you press and hold your scroll wheel down, that will allow you to pan around in the network. If you have a good idea of where you are and you don't really need the background, then you can always click the little globe button up at the top, and this will turn off the background map so that you only see the Visum map. So again, clicking the globe will turn on and off the background maps So that way you can more easily see where you are or see what your actual Visum network is doing. You can use the drop down next to the globe to pick between different map providers. So in this case, we're using PTV Black Marble. This is like a dark screen variant of OpenStreetMaps. So that way it's easier on your eyes if you're working in an office a lot. But we have the PTV default, which is your default OpenStreetMaps, which is a lot brighter. You also have access to Bing Maps. So if you select Bing Maps, this should be your live aerial imagery. So this is all here to help you kind of orient yourself or your customers or whoever's viewing the model, as well as identifying where you are. We also, in version 2022, added this little icon right here where you can actually type in specific cities or locations. So this will allow you to, for example, type in Tallahassee, and you can actually search and it will take you to that location. So we now have these an internal search feature, so you don't have to start at the global level and zoom in on Tallahassee. You can just search for it in the search box. Here in the Tallahassee region, we have some additional colors happening. These are our private transportation and public transportation bars as well. So for example, these dark blue bars, we can see all of the bus routes and see what the trips through the public transportation are. If you want to see the whole network again, rather than having to zoom out, there's this convenient button up at the top that says display entire network. It looks like two little arrows pointing to either side. If you click that, it will zoom out and kind of show your entire network in the network editor. Okay. So now that we have a little bit about, oh, question just came in. Somebody asked, if I close the marking tab, how can I reopen it? So if you accidentally close any of these tabs, that's what the view menu is for. So you should be able to go in here and find the marking tab specifically, tool windows, and then marking. So for example, if you accidentally close your network editor, you can come back into view and say network editor. And that allows you to quickly open up any sort of windows or panels that you have accidentally closed or anything like that. We also have in the file menu, I saved if you go into the graphics section, I saved a training start.gpa file. So if you've gone through and if you find yourself throughout the course of the sessions moving your windows around or something like that, and everything gets a little too mixed up for you and you kind of want to reset, this is a great opportunity to show you how a graphic parameters file works. Basically, all you have to do is go into where it says graphics, and we've saved all of our graphic parameter files here. And if we take this training start.gpa file and left click and just drag it onto the network editor or into Visum, we should get this graphic parameters toolbox that comes up. And you just say read all graphic parameters and then click OK. And this again doesn't affect the analysis or the results of your model. It just affects the graphic parameters of the model. So it kind of resets all of your window positions and what all of the links and nodes are saying there. All right. So now that we kind of feel a little bit more comfortable, hopefully with manipulating the interface, again, we're going to come back to some of these windows. Like we'll come back to this matrices window in a little bit. We're going to come back to the quick view window in a little bit. We're going to talk about the procedure sequence in more detail. But for now, let's start at the basics, and we're going to start by talking about specific network objects. So the first object that we're going to talk about are the nodes. Now, if you're talking about building out a new project, a good workflow, if you don't have any other workflow, if you're not really sure what to do, it's just to start at the network objects and kind of work your way down, top down. So we're just going to kind of talk through it in a similar way. The nodes are junctions between different facilities. So if I zoom in on somewhere like Pensacola or Tallahassee, if I zoom in really close on some of these downtown areas, for example, I'm going to turn off my links by clicking this box here, and I'm going to turn on my nodes so I can see all the nodes in the network. If I zoom in far enough, the nodes are acting as intersections. They're also acting as links between different facilities. So you'll see nodes in the middle of the links here because these are connections to the zones, for example. So this is where the demand is coming in and out of the network. Sorry, just one second. Got to catch up in my PowerPoint. All right, so the nodes by default will act as junctions between your facilities. So they'll act primarily as intersections, but again, there's some few other places that you're going to see them, such as merge and diverge points as well. Anywhere where two links come together or split apart, there's going to have to be a node at that location. In addition, you might see nodes in the middle of a link because some sort of attributes about that link have changed, such as speed or number of lanes or capacity or something like that. Something has changed on that link, and so the node is acting as where is that change point happening on that link. And so in addition to at merges and diverges and intersections, you might see nodes kind of mid-link if it's changing from 55 to 65 or something like that. From 3 lanes to 2 lanes. Another place you'll see nodes are at the end of the network. So nodes will act as the boundary points of the network. This is where things like zones will connect to your physical network, right? This is where the abstract network of the travel demand model kind of meets the physical network of your roadway model. So that's another place that nodes kind of represent. You can find all the nodes in our nodes list. So if I quickly switch back to the Zoom, we can right-click on our nodes in the network object list here, in the network objects list here on the left. If you right-click on nodes, there's an object that says list. So you can open up your nodes list here. So again, right-click, hit nodes list. In the nodes list, this is where you have access to all the attributes of the various nodes, such as ID numbers, node type numbers, control type, as well as here we have some user-defined attributes that are used in the travel demand model for different types of import functions. So a lot of these are attributes that were imported from the external network that we used to initially build the model. And so in the nodes list is where you can edit and manipulate all of the nodes in your network. And so we had a question, for example, do we have a way to control the node number? And that's where you can come into the nodes list and you can actually change the node ID here. Now in Visum, each node has to have a unique ID. And that's fairly common for pretty much every other model that at least I've seen. But if you need to change it to, for example, if you want to match it up to what the physical ID is out in the field, then you can come in here and adjust your node IDs in the list. Any attribute that you see in this list that has a white background is editable. Any attribute that you see in the list that has a gray background is calculated. So for example, this one says vol PRT. This is the volume that was assigned to the node. So after the assignment, how many total trips were run through this node? There was 11. You can't manually adjust that because that's an output of the network. You can manipulate what you see in the list based on a couple different ways, but we have some pre-built ones. So if you look where it says select list layout, if you use this drop-down, we don't have any predefined list layouts, but you could configure your list and save it here. There is also an option to select various attributes. So right next to the list layout option, there's a button right here that looks kind of like a little wrench on a calendar. If you click that button, you should get this interface that pops up. And here on the left side, we can see all of the available attributes associated with the nodes. And again, I clicked this button right next to where it says list layout. There's a little button with a little screwdriver on it or something. And in this window, you can see all of the various attributes on the left that the node has with it. And if we scroll down, you can see the green dots are the default attributes that we have in the network, and these little ones with the little person, these are all user-defined attributes. And you can always create new user-defined attributes by clicking this button up at the top. We also, since everything is tied together, it's a cohesive network, so all of the different layered objects are tied together. You can come down to the very bottom, and these little arrows show the different objects that are associated with this particular node. So for example, we can look at all the turns in this particular node. We can look at all the links coming in and out of this particular node. So they're all linked together. And then on the right side, this is what is actually displayed in the list. So each one of these objects represents a different column in the list. So if you wanted to configure your list to show very specific types of data that might make it easier for you to edit or review the simulation results, you can configure your list by selecting an object that you like or an attribute that you like, and you click the little green button, and then you'll add it to the list over here. You can just as easily remove something from the list by clicking the green arrow that points to the left and removing it from the list. And so that way you can configure what does your list display, and what information do you not really need to display right now. Just because an object or an attribute is not displayed doesn't mean that it's not used. It just means that it's not being displayed to you visually. All right. To close the nodes list, you can just click this little X down at the bottom, and that will close the node list, and that should take you back to your network editor. One last thing about the node list that I just forgot to mention was that if you have your node list detached from your network editor in some way, so for example, if I put it off to the side, if I select an object in the node list, it will take me to where that node is in the network. And similarly, if I click on a node in the network, it'll show me where it is on the list. So if you're trying to perform quality control, or if you're trying to edit a particular node, it's pretty easy to come through and just find that node either in your network editor or find the ID number in your list here. Okay. All right. One last thing is we can configure our graphic overlays to display the nodes in different ways. So in this case, what we can do is right now in the Visum model that you're seeing, the nodes are displaying the unique ID number of the particular node. So if I switch back to my Visum network just real quick. So what we see here displayed in our network editor is the ID number of the node. But maybe we wanted to show something different, like the volume going through the node, or if we just wanted to show them as dots as opposed to having any text. Well, that's where the graphic parameters come into play. So what we can do is we can go to graphics and we can go to edit graphic parameters to open up the graphic parameters menu. We can also get there by right-clicking on the nodes themselves and just selecting edit graphic parameters. That's another shortcut that we can do to get to the nodes graphic parameters. So let's say, for example, we don't want to see the ID numbers of the nodes in the network. We just want to see them displayed as blue dots, for example. So in this case, what we can do is we can right-click on nodes and we will say edit graphic parameters. And this should open up your graphic parameter editor window. And so here in the edit graphic parameters window, we can see we have our different layered objects on the left, and we have nodes that are displayed right now. So in the node configuration, we can see a preview of what the node looks like. And so right now it's showing a text object. But what we can do is we can just as easily switch this from a text object to a symbol. And so now it'll just display the node as a singular dot. If I kind of move this off to the side, we see we have this node 11,738. I can hit preview, and we can see now it's been changed to a little blue dot. So you can always change the size number. So I can make this, for example, a 2 and hit preview, and we can see it's gotten a little bit bigger. Might make it a little bit easier to see. If I click OK, now all of our nodes show up as simple blue dots. And if I hover over them, my ID number comes back up. So it makes it kind of easy to see the ID number of particular nodes. Okay. If you like this particular graphic setting, you can always go into the File menu and go to Save File As. And if you save the graphic parameters file, it will save your node settings as is. So once you've configured your graphic parameters for all of your different objects, you can save it as an independent graphic parameters file, so you don't have to go through the configuration process over and over. Okay. The next object that I want to talk about are the links. The links represent facilities between the nodes. So a link is typically going to represent a roadway. It can be a one-way street, it could be a two-way street, it can have one lane, it can have multiple lanes. Basically, this is where you're going to configure the cross-section of the traversable path between two areas. Links can also represent sidewalks and bike paths, or any kind of transportation structure that your movements would go over. So for example, if you had a cohesive network, you'd have your roadway network represented by links. You can have sidewalks or walkable paths, for example, through a university, that would then link up with nodes or public transit stops on the roadway links, and so you can have multimodal trips traveling between different link structures, right? So you can have somebody walk to a bus stop that then goes downtown, or you can have somebody drive to a park and ride that then moves that takes a walkway link over to a transit center or something like that. Or if they're making transfers between stops, you might need to have a sidewalk that allows, or a pedestrian path that cuts through campus that you can go from one stop to the next. Okay. Here's some of the attributes that the links contain. The big ones are going to be your physical attributes, such as number of lanes, your roadway name, your curvature, the distance that the link traverses, as well as speed. But they also output data as well. So you can look at a link and see what is the travel time on that link, what is the actual assigned speed to the link based on congestion, what is the level of impedance, things like that. So I'm going to switch back to the network editor, and I'm going to turn off nodes, and I'm going to turn on links so we can kind of see the link structure again. Now, once you select, make sure you select the links object. If you have nodes selected, even though visually they're turned off, it's still going to try to find a node for you to click on. So you can still edit the nodes even if they're not visually represented. Now, what we're going to do is we're going to turn on the links layer. So we're going to select the links layer so that we can edit some of the links. And so just find a link somewhere in your network editor, it doesn't matter where, really, and we're just going to double click on a particular link. What you'll notice is that each link has two directions associated with it. So depending on which side of the link you click on, it will display that direction of travel. So in this case, I can pick my eastbound or my westbound link. If I click, for example, down below, if I double click on this link, where'd my link editor go? There it is. It will open up the link attributes for the eastbound direction. So here we can see what link type is it. In this case, it's a divided arterial unsignalized 45 miles per hour. What link types represent are basically, templates for your links. So if you're building a new link, you can use these link types to autofill a lot of the information about the link. So in this case, this link allows for both SOV and HOV and truck traffic. And here we can see down below in the basis tab, we can see the link length is just over a mile. The free flow speed is 50 miles per hour. It has 2 lanes in the eastbound direction. And it has in this case, it's a daily capacity because we're running a daily model of 34,400 trips. And we can also see the current volume to capacity ratio after assignment is about 58%. So what this is representing is the assigned volume. We have 20,000 trips assigned out of 34 available capacity. So we have a 58% volume capacity ratio. Down in the lower section, if I click the opposite button, you can see how now the other arrow is also lit up, and so we can see the opposite direction. In this case, the link is the same in both directions, regardless of which way we're looking. It seems to have the same capacity. It seems to have the same speed and the same length and the same number of lanes. But you can see how this volume that was assigned to it is a little bit different. There's about 600 more trips per day traveling westbound than there are eastbound. You can cycle through some of these tabs down below to see what kind of attributes are assigned to this link, so we can see some of the importable attributes. We can see the output for our private transportation. For example, we can see V0 is our free flow speed, V-cur is our assigned speed. So people are going slightly slower than our free flow speed, but not too much slower. They're pretty much at free flow. We can see T-cur is the anticipated travel time based on V0. And then T-cur is our actual recorded travel time after the assignment. So you can kind of see this delta is going to be your delay on this particular link, which is only 2 seconds for 1 mile of travel. You can see your assigned volume based on the different vehicle classes, essentially, your different demand segments. And then you can see the level of impedance for each demand segment as well. Now, if you want to look at this in mass, just like with the nodes, we can look at this with the list level. So if you right-click on links and select list and go links, you can see all of this data as well in the link list. Sorry, we have a few questions coming in, so I'm just reading through those real quick to see if any of these are on the fly.
Make sure to mention that zones and nodes are different objects.
Yeah. Yeah, that's gonna be the next thing. Okay. So again, your nodes are acting like your intersections and your changes between facilities. So what you'll see is if you have both nodes and links activated, that there should be a node at the end of every link. And so you'll see here's a couple junction points where links are coming together. And so those are what the nodes are representing. The links are representing the actual drivable facilities themselves. The next thing we're going to talk about are the zones. Now, in the Zoom, zones and nodes are different objects. If we zoom all the way out, I'm going to turn off the links. I'm going to turn off the nodes. And here we have different zones in the network. Right, so we can see different zones that are, in this case, represented spatially. They have a geometric shape to them. They don't have to have a geometric shape. For example, if you have external zones, for example, if we had zones that were going out to Georgia or something like that, you could have just a single point zone. It doesn't necessarily have to be a regional kind of thing. But the zones represent demand generators and attractors. So let me get back into the PowerPoint real quick. So zones represent demand generators and attractors. Now, sometimes in other modeling, these are nodes are kind of like represented as zones, but in Visum, they're different objects than the nodes themselves. Again, the nodes represent junctions, and the zones are the actual demand generators and attractors. Nodes don't generate or attract any demand. They just act as gateways between links and the connectors. So what the zones do is you're going to be assigning various attributes to your zones, which may include population, enrollment, employment, housing, things like that, tourist attractions, things that will generate and attract your demand. Oh yeah, and so as well as socioeconomic data. Sorry about that. Yeah. You'll contain all of your population data and stratification in your populations at the zone level. And then we'll use various calculations and things like that to distribute the demand eventually into your, sorry, I'm going a little fast here. Just backing up a bit. So you'll use this population data to then develop your OD matrices in your assignment. So if we jump back into Visum, we have our zone data here. If you right click on the zone object and then go down to where it says lists, you can see your zones list here. And in our zones list, we have a lot of different columns that represent different attributes. We have a predefined list if you use this dropdown called Panda. And what this does is this kind of aggregates, this is used as part of the assignment procedure and part of the population synthesis procedure. But here, this gives us a good summary of what's going on with the different inputs that we put into the zone. So here you can see productions for different types of households and things like that for each of the zones. And so here you can input, single family housing units, multifamily housing units, employment data, enrollment data in schools, and then you'll take that and you'll use that data in your procedure sequence to generate trips and then also attract trips as part of your trip distribution. So if we're talking about a traditional 4-step model, for example, where you might have trip generation, trip distribution, mode choice, and assignment, the trip generation and trip distribution level all take data at the zone level to influence how they distribute and generate those trips. The zones then connect. So if this is our zone map, and again, what I'm going to do is I'm going to turn off the labels so it makes it a little bit easier to see the zones. So I'm going to right click on the zones and I'm going to say edit graphic parameters on my zones. And I'm going to switch it from a text box to a symbol. Or actually, I might turn off the draw object in total. So I don't really want a symbol or a text object. I just want to see the boundaries of each zone. So in this case, I'm going to take and say where it says draw point object, I'm just going to uncheck that box. And when I click preview, you should see that it turns off all of the labels altogether. So we can just kind of see what the zone structure in the D3 model kind of looks like. So again, to get to this point, I right click on the zones object. I say edit graphic parameters. This takes me to this editor here where I can turn off the point object, which is, in this case, the point object is just the display object that's either displaying a symbol or it's displaying some sort of information about the zone. So this is what our zone structure looks like. So for example, if I zoom in on the Pensacola region, you can see that kind of in the outlying areas, the zones are bigger, but as we move into the downtown area, the zones are getting much smaller. And so zones can represent sections of the city or city blocks or what have you. If I turn on my node structure, you can see how some of the nodes are acting as intersections, and then some of the nodes are kind of mid-block on these intersections as well. And the reason for that is because each zone connects to the network using something we call a connector. A connector is kind of like a special link that goes between the zone centroid or the zone center point and a nearby node. So again, nodes act as kind of gateways between different facilities. And one of those facility types is going to be a connector. So a connector doesn't represent like a physical object in the network. It's representing a driveway or an access point to the zone. So for example, if your zone is representing a downtown city area, a few city blocks, the connectors might be where the parking garages are. And so they're connecting to your your nodes wherever the parking garage access points are, right? And so again, the zone connectors are going to act as connections between your abstract zone data network and your physical node network data. So in this case, this is where when you're doing your trip distribution and your trip assignment, those trips are going to be going from zone to zone, but they're going to be getting from zone to zone by connecting into your physical network on one of these connectors. In between these four objects where we have nodes, links, zones, and connectors, these are kind of the basis of every Visum model that you're going to see, right? So you're going to have your nodes representing your intersections and your gateways between facilities. You're going to have your links that are the physical drivable roadways between them or pathways between the nodes. And then you're going to have your zone structure, which is determining your population data, your employment data, your enrollment data, your socioeconomic data. And then to get from the zone into your physical network is the connector. Okay. Now, beyond those four types of data points is kind of in parallel to all that is your public transit network. So in the Tallahassee region, for example, we've gone ahead and put in all of the transit stops as well as transit lines that are in the model. And so in this case, we can see the transit stops, which define points between public transit modes and private transportation segments. So the stops kind of sit on links or they can sit on nodes. But what they represent is kind of junctions between, for example, pedestrians and public transit vehicles. So it can represent a curbside pickup drop-off. It could be a lay-by stop. It could be a whole transit center, or it could be a park and ride, right? So in this model, for example, we have park and ride and kiss and ride trips where drivers are doing the first mile, last mile as private transportation, and then they basically will travel to a node through the links, but they'll travel to a node that represents a park and ride, and then that park and ride will have a transit stop associated with it, and then from that park and ride you will have your public transit trips dispersing from that location. And in between those stops, you're going to have public transit lines, which define the headways, the riderships, the fares. And then you have the public transit routes, which are the actual specific link sequences and stop sequences that the vehicles are going to be following. The public transit routes, they can be loops. They can be just one direction lines. They can also double back on themselves. And so these public transit lines, they can represent bus loops, they can represent light rail, they can represent streetcar, basically anything with a timetable that services public transit stops, you can represent as a public transit line or a route. Okay, so before I get into...
Just make sure to let them know that it's not necessary to have a timetable, because all of the assignments over here are headway based assignments.
Okay, yeah.
So we support all of those.
Yes. So Chetan just wanted me to point out as well that we could also, you don't necessarily need to have timetables because our assignments can be headway based as well. So we kind of support all of that as well.
That's the case in this model.
Yeah, and in this model, it's not a timetable based, it's a headway based model. And we'll look at that tomorrow afternoon, tomorrow in the later half. We're going to be putting in new public transit lines into, we're going to be creating a couple in the Pensacola region. And so we're going to be adding in some transit lines and some transit stops that are actually real world conditions. And we'll be looking at how we can add that to the network. Okay, before I move on to the matrices portion, I want to jump back into the model just so you can see what it looks like in the actual model. So I'm going to turn off my zones real quick, and I'm going to scroll down until I find my public transit stop areas, or sorry, public transit stop points, and then we have our public transit lines. You can see in the Tallahassee area, we have a lot of them that we've already put into the network. So you can see the yellow triangles are representing the actual stop points of the network, and then the blue lines are representing the actual transit lines through the network. So if I select the object that says public transit lines, you should get this interface that comes up, and you can see all of the lines in the network. So here are all the different lines that we have in the network between Star Metro and FSU. And then here are the specific line routes, because we can have some lines that have 2 directions. So in this case, we have 1 direction for most of these. I think they're all kind of represented by 1 specific line. But if we click on a line route, you can actually see the line route that is taken through the network. So you can kind of select through these and see what routes do they represent in the network, and what stops are they servicing. So again, to get to this point, what you have to do is you have to activate your public transit lines visually by clicking the little white box next to the lines. And then you select the lines object to bring up this lines editor window. And you can use this editor window to pick between different lines in your network and kind of see their actual courses through the model. And again, tomorrow, our 3rd example is going to be adding public transit lines. So we're actually going to work through this tomorrow and build out an actual transit line with stops and everything. Okay. All right, so once we have all of our links and nodes and zones and connectors and transit vehicles in the network, the next thing we're going to do is we're going to tell Visum how many trips are going between those zones, and are they going to be private transportation trips? Are they going to be public transportation trips? Are they going to be people using public transportation rather, or are they going to be using private transportation? And so in this case, what we're going to do is we're going to define matrices. And the matrices come in 2 varieties. We have matrices that represent demand. So here are all of the demand matrices that we have in the network. These contain trip counts between zones. Now, the reason we have so many matrices is because we use these in both the pre-assignment process as well as the assignment process. So some of these matrices are representing subsegments of the population, right? They're representing how many different types of single occupant vehicles or multi-occupant vehicles or park and ride trips do we have between different zones under different conditions. And then what we can do is we can combine them together. So you can see how we have different matrices on this left side that represent different types of park and ride and kiss and ride and single occupant. And those all get combined together into an overall total matrix for single occupant and HOV and truck. And then those are then combined for the assignment process later on down the road. So in this case, you know, your default, your standard OD matrix represents trips between 2 zones. But it doesn't have to be total trips. It can be some subsegment of your population. The other variety of matrices that we have are called Skim matrices, and these represent some sort of non-trip based data between the zones. This can be, some examples of this are level of impedance between the zones, travel time between the zones, trip length between the zones. And these are used again in the pre-assignment process as well as the post-assignment analysis, right? So in this case, you can use skim tables to or skim matrices to help develop your transit network or your transportation network before the assignment process, using it for various adjustments and optimizations that you need to do. And then you do your final assignment, and then you can pump out even more skim matrices that are giving you output data results as well. To find the matrices, these are going to be, if I'm just going to select something like nodes, for example, just to kind of get off of get that image, that interface out of the way. So I'm just going to make sure I pick nodes in the network objects. The matrices are actually in a window that is stored behind the network objects. So if we look here, here's our network objects list. Down at the bottom, there's a tab called network, and there's a tab called matrices. So again, the network tab represents all the physical objects, and then the matrices offers a list of all of the matrices that we can have in our network. So if we expand our list of matrices, let's expand, for example, our list of demand matrices. So if I hit this plus button, it's going to ask me about zone matrices. So I'm going to expand that. And in this case, I'm going to have my basic data matrices. We have data matrices and formula matrices. These formula matrices are based on calculations that are done. But we're going to look for now at the data matrices. And these are kind of like our input values. And we're going to take a look at how we can observe the values within one of these matrices. So looking at these data matrices, we have quite a few of them, but I'm going to double click on the one that says 77 SOV. So if I double click on this matrix, it'll open up my matrix editor window. So again, behind the network objects, there's a tab that says matrices. Let's find the one that says single occupant vehicles. And we're going to double click on it, double left click on it, and it'll open up your matrix editor window. Anytime you add a new zone to the network, it'll automatically add a row and a column to our matrices. And again, how you'd read this is these are the origins are the rows and the destinations are the columns. So in this case, if I click on a particular cell, this is all of the SOV trips that are going from zone 2 to zone 5. And again, since we are running a 24-hour model, this is a full day model, so this is number of trips per day between these two zones. If my matrix editor was detached from my network editor, so if I do something like this and kind of put it off to the side and look at my network editor, if I click on a particular cell, it should show up on my network editor. There it is, right there. Just took a second to kind of do it. But what this is doing is this is showing from zone to zone which zones these are going from. So if I activate my zones, for example, there are just almost 2 trips going between these 2 zones in this particular direction. This guy?
Yeah, so it's a little bit further out.
Yeah. Yeah, here's another selection that we have where the zones are a bit farther apart. So you can see the number of trips going between multiple zones. And then they have to find paths between these 2 zones as part of the assignment process.
Multi-selection. Yeah. Just 3 or 4 from there.
And if you select multiple rows or multiple columns within one, you can see all of those also labeled in the same kind of area. So if I highlight these, for example, you can see all of the inbound trips coming into the zone from the other zones that you've selected. All right. So let me redock this real quick. So this matrix editor, we don't necessarily develop this. We don't necessarily develop this by hand. The matrix editor, it can be filled out by hand, but if we look, we have 3,500 squared number of cells. So typically the trip generation, trip distribution is going to be an automated process that will help fill out this matrix. But there are ways that we can go through and we can edit the matrix in a more automated kind of way. So let me open up my PowerPoint real quick. One of the ways that we do it is we start with an import of some kind. So you might have an external matrix file or something like that that you would like to import into the network to kind of autofill some of these zones. That's an acceptable way to import the data or to bring in large amounts of data. Another way is that we can apply operations between existing matrices. So for example, the matrix we were just looking at was the total SOV matrix, and that's a combination of all of the sub-trips that were generated through our trip generation. So you can apply various types of operations to the matrix. In this case, what we're showing on this as an example is you can take a matrix and just multiply it by a particular factor. And so this will take every cell, in this case in matrix 36, and multiply it by 1.03, as that might be some sort of uniform growth factor. You can also combine multiple matrices together. And so by doing this maybe represents something where you have different subgroups of, or different submodes of transportation that all would feed together, for example, into our single occupant vehicles total trip table, right? And so in that case, what you would do is you would combine all of your single occupant trucks and all of your single occupant passenger cars, and you'd combine them all together into one SOV trip table. You can also use this combination of matrices and vectors to combine matrices that maybe don't have uniform growth, right? So you're looking at something like a 2025 projection or 2045 projection, and you want to have different growth based on different zone values, right? And so in this case, each zone might have a slightly different growth rate. And so in that case, you can create a matrix that just holds the data about the particular zone growth rate and combine it with a matrix of trip tables, right? And so in that case, you can have an ununiform combination of matrices and vectors as well. A lot of this process, though, is going to be automated. So we're going to put that into, we've put that into the procedure sequence as part of the trip generation, trip distribution. So a lot of these tables are going to be updated automatically. We'll see that tomorrow when we do a land use update. That's going to be one of the first examples that we do tomorrow, where what we're going to do is we're just going to change some of the population data within our zone model, and then we're going to rerun the procedure sequence. And what that will do is that will go through, and the procedure is set up to look at that population data and redistribute the trips accordingly. And so a lot of this process is all already automated, and so all we need to do is just change the inputs at the zone level. Okay, so real quick, I just want to pop back over into Visum. Where is my Visum model? It's right there. There we go. So at the matrix level, again, you can open the matrices here. You can perform different operations on a particular cell. So you can pick a cell, and then up at the top, we can add to it, subtract from it, multiply it, things like that. In our procedure sequence, though, down at the bottom of the screen, if you select procedure sequence, we have a lot of these procedure steps that say combination of matrices and vectors. And so what this is doing is this is developing those matrices for us in an automated process. So what we've done is we've gone through and we've predefined some of these formulas to generate the matrices so we don't have to necessarily go through and do that by hand. So our procedure sequence as part of the trip generation step has all of these combinations of matrices and vectors. It's doing this process in an automated way. But if you wanted to come in and subtly change something here or there in a particular cell, or if you wanted to do something like a TIA, you can create a matrix for a specific TIA that would represent certain trips that are added or removed, right? Something like that. Okay. The next step, after we have our matrices in place and built out, so we have our zones built, we have our nodes and our links built, we have the zones connected to the nodes with connectors. Then we take the matrices, which define the number of trips between the zones, and we have to assign those matrices to their specific modes of transportation. So in the Visum model, we have a matrix called SOV, but it's not necessarily, Visum doesn't know to assign that to the SOV mode of transportation. So that'll be the next step, is that we have to come through and assign the matrices, the trip matrices, to specific modes. And we do that in the demand menu. So the first thing we'll do is define what modes we have in the list. And so in this case, we have kiss and ride, we have park and ride, SOV, SR2, SR3, and then we have different, we have trucks, and then we have transit. Transit W, TRW, is representing things like walk trips and transit trips and things like that. So it's kind of the multimodal, anyone that would use transit that is not using public or private transportation would use that transit network. Then what we do is we combine those different modes that we had. We take all these different modes of transportation, for example, kiss and ride, park and ride, and transit, and we would kind of combine them all into demand segments. So somebody that would, take a kiss and ride, they would take the kiss and ride aspect as the private transportation part, and then they'd take that to a public transport stop, and then they get on public transport stop, and then maybe they walk to work from there. And that is a demand segment. So what we're going to do is we're actually going to assign the matrices to the demand segment level. So you're going to have your SOV, your transit trips, your HOV trips. Those are all going to be assigned at the demand segment level, and that's in the demand data menu right here. So let's jump back into Visum real quick and kind of see where that is. So we have our single occupant vehicle matrix that is developed. If we go into the demand menu and we go to transportation systems, modes, and demand segments, you should get this menu here. And again, that's in the demand menu, demand, transportation systems, modes, demand segments. And if we click on the demand segments option, you can see the different modes that are assigned to our single occupant vehicles. Here we have our mode SOV. Here we have SR2 and SR3. You can see SR2 is assigned to HOV, SOV is assigned to SOV. But if we look here for our transit, off-peak, and peak, those have these various transportation systems and modes assigned to them. So we have transit walk, we have project bus, we have local bus. Those are all assigned to specific modes, and then they are assigned to specific off-peak or peak transit periods. Then if we go into the demand menu and we go to demand data, you can see that we have different matrices assigned to each one of these modes. So here for the SOV, you can see we have matrix 77, which is the one we were just looking at, is assigned to our SOVs. So this is now us telling Visum all of these trips in this table 77 are considered single occupant vehicle trips. All right. And then once we have our demand segments associated with a matrix, what we can do is we can click out of this. And if we go to our procedure sequence, there's a lot of procedure steps. There's 124 procedures, but a lot of this is your trip generation and trip distribution, right? So you see combinations, we see a trip distribution, combinations of matrices and vectors, trip distribution, combinations of matrices and vectors. Some scripts are running, more trip distribution is happening. So what we're doing through this procedure step is we are taking that zone data and we're developing the matrices from it. We are then synthesizing the population and distributing it amongst the other zones as trips. And then if you keep scrolling down, eventually we're going to get down to the point where we have this one procedure step right here that says PRT assignment. So we've gone through all of this process of creating the trip tables, or the OD matrices, I should say, not trip tables. We've created all our OD matrices, and then we've assigned them to our different demand segments. We've linked them to our different demand segments, and then we have our PRT assignment, which is actually taking those vehicle trips, and they are now assigning them to paths in the network. So this is what is actually loading the volume into the network, is this equilibrium biconjugate Frake-Wolf assignment that we are running in this particular model. What we've done to make this a little bit more organized is we have different groups. So these yellow bars are just representing group titles. If you right-click on one of these yellow bars, you can say collapse all groups. So right-click on one of the yellow bars, you click collapse all groups. And now you can see that we have all our group titles here. So you can find from the procedure group titles, here we have prepare trip tables and assign flows. So if you double click on this row, it'll just expand this one section. So if this is all you're concerned with looking at for now, again, right click on one of the yellow rows and say collapse all groups. And then you can find the specific group of executable procedure steps that you want to look at. In this case, just the PRT assignment. Looking at this procedure in a little bit more detail, it's grouped together. We have our trip generation sections. So here, this is where it's basically taking all of our zone data and it's putting it in as origin data. And then we have our trip distribution sections. And what our trip distribution sections are doing are taking that origin data trips and they're saying, okay, which zones do they want to go to based on the attraction level of different zones, employment, enrollment, things like that. And so these chunks of groups are all distributing those initial trips. So we get a total volume of incoming trips into the network. Where are they all going to? That's what this section is doing, all the way down to here. So this whole group is doing that. And then finally we get to the assignment section. And then after assignment, we have post-skim updates and then summaries as well. So we're doing some post-assignment analysis and logging of data. And then from there, we can get our results from the network editor itself. So once you run through that assignment or that procedure sequence, you can then get to the point where you have a loaded network of links with different volumes and things like that on the network. One last thing about the procedure sequence is that there are some operations that Visum can do that we don't have in this particular model. For example, if we go into the procedure sequence and click the create option under operations, you can see we have things like cycle and split optimization, offset optimization, signal offset analysis, If you're working on developing matrices, you can do demand matrix correction, and some other additional automated processes that we can incorporate into our demand models. So Visum has a lot of flexibility in that sense. In this case, it's a pretty straightforward model that we're running in this particular example, because we're doing trip generation, we're doing trip distribution, and we're assigning the model. All of our nodes in this case are just running off of impedance, as opposed to, I don't think any of them have any sort of signal control, right, in this one, Jaden?
No.
No signal control in this one, yeah.
This is kind of like some of the signalization, signal offset, that's all for supporting multi-resolution applications.
Okay, yeah, that's a good point. Just pointing out that the signal optimization and things like that, that has a bigger impact on things like if you're running SBA, or if you're looking on, which is simulation-based assignment, which is the meso kind of level.
Multi-resolution.
Yeah, multi-resolution modeling, and if you ever want to push it out to Visum or anything like that as well. Okay. All right, so at this point, we've kind of gotten to the point where we talked about all the basic inputs into the network. Again, tomorrow, what we're going to do is we're going to get into the nitty-gritty with some explicit examples about building a new build. We're going to do a transit build, we're going to do a land use build, and then a physical network change. Just make sure that as you're going through the models, you're clearly saving your models as you go if you're making a lot of changes or anything like that. We always recommend saving early, saving often. You know, you don't want to lose any of your data or anything like that. After the break, we're going to cover scenario management and talking about how you deal with multiple different scenarios. How can you combine the data of different models together to compare and contrast them? So as far as basic interface overview and model inputs and outputs go, this is where we're going to take our break.
So there are a couple of questions here. One is about creating user-defined attributes.
Okay.
And another one is about splitting links.
Yep.
So let's show the generic user-defined attribute for any network object, and you will be taking a network editing exercise in which you will show splitting links and such, right?
Yeah. So that'll be the first. So for those of you, how the break is going to operate is if you want to get up and go get a coffee or something like that, that's totally fine. The session's being recorded. So if you miss any questions or anything like that, but we're going to take this time to kind of field some of the questions as well, do a quick Q&A. So if you need to take a break or anything like that, we're going to do a couple questions here. Then we ourselves are going to take probably about a 15-minute break, and then we'll field a couple questions when we get back, and then we'll get back into it. But one of the questions we had was covering user-defined attributes. If we can look at those a little bit more, there's a few different ways that you can look at user-defined attributes.
The question is specific to creation.
Yeah.
So just how about describing the workflow for creating a link user-defined attribute? Okay.
So you can go into the network, and there's an option to create user-defined attributes generically here. And so you can, in the network tab, if you go to network user-defined attributes, this is one place where you can create user-defined attributes. And you hit the little plus button, and you select the object type that you want to create a user-defined attribute. That's one way to do it. Another way that you can do it is just by going into the link list itself. So if we open up our link list, you can come into the select attributes option, and then you can directly create a user-defined attribute here. So if you're already at this location, you don't have to like exit out of it or anything like that. Both avenues will take you to this same interface window. So again, if you're in the link list already, you can come into this little button right here that says select attributes and click the little person icon up at the top. That'll take you to this location. Otherwise, if you want to do it more generically, you can go to Network, open up the user-defined attributes list, and then click the plus button. Select the object that you want to create the user-defined attribute on. In this case, it's already on links, so I'm going to just click OK, and it'll take you to the same location. Now here, if I quickly, before I want to do that, I want to have my link list open just so you can kind of see what attributes look like. So if I go into my user-defined attributes, I'm going to put this off to the side, sorry. Just 1 second, kind of organize, make it easier for you to see. All right, so we have our link list shown. I'm going to create a new user-defined attribute for links. Now in this part, what you'll do is you'll define an attribute ID for something on your links. Do we have an example? Did the question have a specific example about it?
Let's say count.
Okay, yeah. So something like counts, right? I'm going to say count, and I'm going to call it daily. So you have some sort of daily count that maybe you want to input as like an input value. So in this case, you're going to define the attribute ID. Now the attribute ID shouldn't have any spaces or anything like that. If it needs a space, you can use an underscore. But what's going to happen is this attribute ID is going to be whatever the header is of your list. So you see here where it says type no, that's representing the link type number. So in this case, make sure that your attribute ID is something descriptive enough and easy to read enough that it can be easily identifiable in your list. And then you can add a comment here if you need more comments. Now down below, what you're going to do is, depending on the type of data, you can select whether it's an integer, it's a Boolean, so is it a yes, no? Is it a currency? Does it have decimal points? Is it a time-based thing? Is it a speed-based thing? So what kind of units does it have? In this case, since it's a count, I'm just going to put an integer. If you need, you can also have formula-based attributes. So you can always create formulas. But for our purposes, we'll just select it since it's a daily count, for example. It's going to be an integer. And then we're going to select that it's a data value right here. When you click OK, this should create the user-defined attribute. And so in this case, if I go into my link list, I can edit what attributes are visible in my network, in my list here. So I can scroll down until I find the user-defined attribute called count daily. So right here, I create a user-defined attribute called count daily. I'm going to double click it, or I can click the little green arrow to add it to the list. So I see count daily here, and I can move it up and down so I can reorder my list. So if I want my count kind of towards the front, for example, I can click OK. And now I should have my count daily option right here. And so I can just now start typing in data. I can also see this attribute if I go back into my network editor and double click on a link, and then go to user-defined attributes. I can hit show all, and there will be a count daily option here, or I can click the rows button and just like before, select the specific attributes I want. So here you can add in your daily counts. You can use user-defined attributes on any physical attribute that we have in the network and some of the non-physical attributes. So for example, if you wanted to add turn counts or link counts or something like that, or connector counts, you can do that. So user-defined attributes are really good tools for performing QC on your network or entering in data points for field data or target expected values as well. If you wanted to create a formula-based attribute, you could create a formula that combines multiple attributes together. So maybe you have like AM counts, AM peak counts, midday peak counts, PM counts, and then you want to combine them together into total counts or something like that. Or you have counts of trucks, counts of cars, and you want to combine them in together to be total counts or something. You can do that as well using formula-based attributes. All right, everybody, welcome back. We're going to get back into it. Just looking through any last-minute questions. All right, so we did have one about zones, about how can we aggregate data between different zones and things like that. And that's where the filters would come into play. You can create territories, an additional object called territories that you can aggregate data within that territory. You can also create things called main zones. And so you can have your existing zone structure set up, and then you can create main zones over the top of that structure and link together multiple zones within a main zone. And then that main zone will act as its own object. And you can do analysis and things like that on the main zone itself. So in this case, the question was, how could we merge zones for summary purposes? Suppose you had 100 zones and want 10 districts. In that case, you can group them together either as territories or you can group them together as main zones. Either way will work for our purposes or for those purposes there. Okay, so Johnson or Chayton, were there any other questions that we got coming in that need to be answered before we move along?
No, I think we caught up. All
okay.
good.
All right. So in that case, the next thing that we're going to cover is how do we walk through managing multiple scenarios. Now, in Visum, we do have a built-in scenario manager tool, and this can be found in the File menu. If you go to File, Scenario Management, and then you can say Open or New Projects, and you can place your file under a scenario manager tool. And what that generally looks like is you'll have this extra window that opens up like this, and you can see all of the different scenarios that we have in the model. This image that we have here is an example from the District 1 training, where we had a 2015 year, we had a 2045 forecast year, and then we had different builds that we worked through in that training. So we created a new build, we created a zone edit option, and we did a transit edit option, and we did those as separate scenarios, and then we could combine them together as a combination of all three. How the scenario manager works in Visum is it's a built-in scenario manager structure that is based on modifications. So the modification structure is that you actually, when you're building out your scenarios, you're gonna build modifications to your base network that you can then deploy to multiple scenarios simultaneously. So for example, if you were to have a new punch through, or you wanted to add a new interchange to, or change an interchange to the freeway, you could do a modification with your freeway, and then apply that to multiple different scenario build potential options. And so what you do is you'd start with multiple different modifications, and you combine those modifications together to create your scenarios. This might be a good one for Chayton. Chayton, there was a question that said, talking about how do we merge data from different zones from a reporting perspective. We're talking about territories and main zones. Do you think you could describe the key difference, like what is a territory versus what is a main zone?
Yeah, sure. So generally speaking, the zone in Visum is your TAZ, and main zones are kind of ensemble, or let's say district zones, which are an aggregation over the zones. These are always connected with the zone. So the parent main zone knows its child zones. And these can be used for on-the-fly aggregations of, let's say, matrices and such. And then also territories are bigger areas, like let's say you want to have a shapefile of an administrative area for, let's say, Tampa, or like a city versus Tampa Bay with the whole area. And you can have all of the counties modeled as territories. And what that does is it gives you a clean container for calculating VMT, VHTs, and such inside a polygon. So that's the general purpose of territories and main zones. Overall, there isn't really a, what do you call it, an official or correct way to use it. So most of it will depend on how the data is aggregated or reported in those specific models of, let's say, various FTOT models or models elsewhere. So these are typically custom defined, which is kind of what you see with the Fusutomus reporting scheme as well, where those tend to be cube scripts, essentially punching out the summaries for what you need. So there are on-the-fly summaries that you can generate with the lists and such in Visum, but then it's also possible to have kind of scripted outputs similar to what you might have seen in the working with Cube and such.
Okay. Awesome. So yeah. Okay, thanks, Chetan, for that. So yeah, we were just clarifying a question that came up, a follow-up question to the question about how can we, if we had a bunch of little zones, how can we put them into, say, districts? And so yeah, you could use main zones for that if you wanted to explicitly combine, if you wanted to explicitly assign zones to a main zone, or you can use territories for larger regions than just districts, for sure. All right. Okay. Thanks for that clarification. Let's jump back into where we were. So again, getting back into the scenario manager tool, this is found in the file menu, and it's modification based. So you're going to create modifications to the base network. You're going to start with modification at the modification levels, and these can be as simple or as complex as possible. As you want. So a modification could be something as simple as you've added one link to the network, or you've increased the number of lanes to one link on a network, or it could be as complex as building out a full new development site, right? And so these modifications can be whatever you want them to be, but they're just edits to whatever is different from the base network. And so what you'll do is you'll create various modifications, and then you'll combine them together to give you your future build. So for example, you might have a land use update to various zones in your network as a modification, and so you'd apply that to all your 2045 models, for example. And so this allows you to create the modification only once. You don't have to go back and repeat the process over and over again. You also don't have to like input and output or import and export these modifications between files. It kind of does it automatically. And here's just kind of like a little visualization of it, where basically you're going to create the modifications as independent entities, and then wherever they overlap, that's going to be what your scenarios are, right? So in this case, you can have scenario 5 be the combination of developments A and B, right? Or something like that. And so this allows you some flexibility to create overlapping updates to your network. And then after that, it also allows you to, sorry, real quick, I went too far. Okay. It also allows you to batch run multiple scenarios at the same time. So basically you would activate which scenarios you want to run, and then you hit the little play button, and it will, you can just hit play and kind of walk away from your desk. So you can do this overnight or over the weekend or at lunch or something like that, depending on how fast your scenarios run and how many you have. So if you wanted to run all of your scenarios at the same time, you could do that, where you can pick out specific scenarios and run them or make edits to them in this way. However, for today, we're not really going to talk about that too much. We already covered it in great detail in the District 1 training using the Scenario Manager tool. Now, using the Scenario Manager tool isn't the only way to manage scenarios. There are a lot of our users that use Visum that do not necessarily use the Scenario Manager tool. They manage scenarios using third-party software or just externally in their files and things like that. And so we're going to walk through that process today. We're going to talk about how can you manage your files in your different scenarios and still compare and contrast them without using the Scenario Manager tool. So if you have any questions about the Scenario Manager tool or anything like that, feel free to shoot them over to Johnson and Chayton. But I'd highly recommend you check out our District 1 training kind of towards the end of that first day 1 video. The last about hour of that video is all about the Scenario Manager tool. And again, that's on our website if you wanted to go check that out. Today what we're going to do is we're going to talk about how do you use different version files, different Visum input files, and analyze the different scenarios between them. So for example, in our file structure, we have a 2015 base model year, and then we have the 2045 forecast year. How can we compare and contrast these different model files that we have between them? Sorry, gotta get my PowerPoint back up. There we go. So let's look at the changes that were made in the 2045 model, and then once we've analyzed those changes, we can compare and contrast it to the 2015 model. So the first thing we're going to look at is in the zones. We can see that the production and attraction values have changed based on differences in the zone structure, right? So we've had some zones added and removed, or not, sorry, not added and removed. Population, yeah, the population and things like that were changed. So the population synthesization was done and updated in that way. The zone structure, you'll see the number of zones is the same between the two. So we have 3,576 zones, they're identical. And if we look at the specific zone numbers, the production and attraction values have changed a little bit. So the actual resultant data within the zones has changed. We can get to this view if you go, like we did before, if you go to the zones list and then use that drop down called Panda, you can look at this. So I'm going to jump back into the Visum model and go to zones. So right now I'm in the 2015 model. If I right click on zones and say list, and then use this list layout, we can look through these attributes manually, but we have a list layout that has all the summary of this data. You can kind of look at the total number of zones that we have and the total production and attraction that we've had through the different courses of the assignment process. And you can see how the production and attraction for each of the zones has subtly changed if I look at here versus if I jump into the 2045 model. So let me pull up my 2045 model. If we go into the zones list, this is the 2045 forecast model. Right click, list on your zones. Use the same drop down for Panda. You can see how the production is 1350 there. And in the 2015 model, it is 10,000 or 1030 there. So you can see how there have been some subtle changes. Okay. So what we're going to do is we're going to start with the process of how would you take the base model and create a new scenario out of it. This is going to be pretty straightforward. Basically, it's going to be like copying the base model and then making changes. The cleanest way to do this is to open the model itself and then save it as a new version file. So in this case, we're going to open up the 2015 base model, and then we're just going to use the Save As option. Again, we do have an inbuilt scenario manager tool, but today we're just going to use the Save As option, and we're going to look at how we can create different version files. Basically, you'll save it as, you'll provide it with a new name, and then from there, we can look at we can make changes to the network geometry data. So when you're within the actual model, it's not that tricky. You just go in here and you go to File, Save File As. Now, for our purposes, we're not going to actually do any updates to our base model yet, just because we're going to do these updates tomorrow. We're going to do a zone land use update. We're going to do a geometric update where we add and change some links. We're going to split some links. And then we're going to do a public transit update. So we're going to do all those different types of actual modifications tomorrow. For today, we're just going to compare the 2045 model to the 2015 model and look at what kind of tools we have to compare and contrast different scenario alternatives. Part of the reason why we're not going to rerun a simulation today or anything like that is just because it takes about 20 minutes to run the whole procedure if we include trip generation, trip distribution, and trip assignment. This is actually fairly quick for a travel demand model. 20 minutes isn't that bad, but in terms of from a training perspective, what this looks like is just you staring at the screen for 20 minutes waiting for a progress bar to finish. And so for brevity's sake, what we've done is we already provided a 2045 model that has been run so that we already have the results of the 2045 forecast model, and we can use that as our sample to compare and contrast. All right, so what we're going to do, and this says 2022, but we're going to use the 2045 model. What we're going to do is we're going to update, or we're going to go into the File menu. And in the Compare and Transfer Networks option, what we're going to do is we're going to select, there's a few different ways we can do it. You can do version comparisons, and what that'll do is that'll create a tracking file. You can also just do it directly, kind of all in your RAM memory. So it won't create an external file, but you can just you can import the data from one model into the next. And what that's going to look like is you're going to select the base version that you want to import. And then when it does import, we'll get to this point where you will be able to see values from the base version, the forecasted version, and then you can actually look at the deltas between the results of the two models, all within one file. So you don't have to post-process the data or anything like that in a database. You can do it all directly within Visum. All right, so before I get on to the graphics section, what I'm going to do is I'm actually going to open up the 2045 version file. So this is in the training directory if you've downloaded the example files. Sorry, I'm trying to get my cursor over there. There we go. So we have our 2045 model right here. Let's go ahead and open that up in Visum 2022. And once you open it up, you should be able to see all the links in the network. If you want, we could also open up that graphics and we can go to the training start. And so this would basically import all the graphic parameters from what we saw earlier this morning in terms of link bars and things like that. So we can compare the link bars of 2045 to the 2015 base model year. That's okay. If you get this little warning, just click OK. That's totally fine. And you can see we have our link bars, and just like we had before, we have our public transport bars in blue as well. So you can, and a flow bundle that has been calculated for this east-west corridor. But what we can see here is we can see the results of our 2045 forecast model. So this is after all of the zone edits have been made to adjust the population data. And then we've rerun the trip generation, trip distribution, and trip assignment. Again, that takes about 20 minutes. So it's actually fairly quick. It's just a little too long for training purposes. Okay, so once we have the 2045 version open, you're generally going to want to open the scenario as opposed to the base model year, because then you can see what's been added, what's been removed, things like that. So if we come into the File menu, we want to compare this to our 2015 base model year. So we're going to come down to Compare and Transfer Networks. And if we go to Compare Current Network with a version file, what we're going to do is we're going to find our 2015 base model year. So in this first section, we're going to say Version for File for Comparison. You're going to click this little 3-dot option. And when you do, it'll take you back to your project directory, and you'll want to select your 2015 base model year. So again, to get to this point, it's under the File menu, Compare and Transfer Networks, Current Network with Version File. Select your base model year here. Click Open. And then you want this version file is the base network.
Currently loaded.
So once you click OK there, uh-oh, my whole screen went black. Something just went funky.
I guess we're having a bit of a technical difficulties at the moment. So give us.
Sorry, my computer froze real quick. Just give me
Okay.
1 second.
So if you have to restart or something, feel free. Let's see. In the meantime, I'll check and see whether there were any questions. Is it back?
I'm not sure. One of my monitors booted me off, so I'm trying to figure out what's going on.
Okay. So here's one question, Chayton. If you're there.
Yeah, I'm here. I was just muted.
So the one question that we've got here is that why do you need different versions of Visum? He's not talking about different years or what, but he's talking about version 2022, 2021, and those type of stuff. like, and he's not talking about the scenarios, but like, just those different versions of our software. Why do you need to, is there a need that you need to keep multiple versions? If so, why would that be the case?
Generally, you don't have to keep multiple versions of the software. Usually when we release Visum, prior to release, we typically run lots of software regression tests on some known large models before the release to make sure that the numerical integrity of the results is maintained. As in, if you install a service pack or go forward, none of the main procedures actually gives you a different result with Visum. So, however, there might be legacy versions that are maintained for legacy reasons. And maybe there's a model migration sometimes that's still in process, in which case another older version of Visum may be maintained for that purpose. But generally speaking, it's not necessary to have multiple versions of Visum. Usually you can open the model and work with a newer version, particularly if there's not a lot of custom scripting or custom tools that are built around one specific version of Visum.
Okay. Levi,
Johnson, are you able to see my screen, Johnson?
Yes, I can see your Visum.
You can see Visum right here?
Yeah, I can see your mouse cursor moving around. Yes, I can see that.
Okay.
Procedure sequence, yes.
One of my monitors booted me off for some reason, so now my graphics are all funky. All right,
yeah.
So.
But like, a couple of questions that came in, like, for you, Levi, is that like, I think, you were trying to do that comparison side of the things. Mm-hmm. And I think, if you can go, a couple of steps back, that would be really great, because I think a couple of people posted some questions saying like, trying to clarify what they needed to do. So if you can go a couple of steps back, that would be really great.
Yeah, just give me 1 second. I'm going to boot up my 2045 model. Okay. Yeah, for some reason I can't get back to my go to training, so I don't have any controls over that. So sorry if everyone's getting a little behind the scenes look here.
Okay. And one more thing for you, Chaitan, while like having like Levi's like getting this situated.
Yep.
So there's one person, Jesse asked about like the case where like they have installed 2021 instead of 2022. Will there be like be that big of a difference, or like this D3 model? I don't know where it's from, but anyhow, will there be any difference like using it? Like could they use 2021 still with this training files? Or is it like, in other words, probably, is it backward compatible?
No, Visum is not backward compatible in terms of the binary file. It's possible to batch out parts of a Visum file from one version or further version and have some of those components read back into an older version of Visum. But generally, Visum does not support backward compatibility directly with the binary file. So if the model binary is already in Visum 2022, you basically install Visum 2022 and work with Visum 2022.
But majority of those like functions and features that Levi's going through is like those are what's available in 2021 as well.
Yeah, majority of those features and functionalities are already available in 2021.
Okay.
2022 added some other functionalities around activity-based model support and some other improvements and variants of assignment methods and such. So those would be the improvements that would be key for the 2022 version of Visum.
Okay.
Right.
I think I'm okay. Just for some reason I can't pop up my my go to training. So, all right. So, can you see my screen though? Okay, Johnson.
Yes. You can see your Visum file. Yes.
Okay. For some reason, my graphics are all over the place. So when I click my file menu, it's not going. Just give me 1 second. Sorry, my computer just died on me, I think. Let's open this. All right, so let me just do this. I'll go into the PowerPoint. So somebody was looking for extra steps. Yeah. All right, so somebody was looking for the steps on how to do the compare and transfer network. So you're going to start by going into the File menu and go to Compare and Transfer Networks. And then once you do that, you're going to select your 2015 base model year. So the key here is that you actually want to do this in your 2045 forecast model. So you'll want to actually open up your 2045 forecast model and then go into the File menu and go to Compare and Transfer Networks, and then select Compare Current Network with Version File. Then once you get there, you will select the file that you want to be your base version. So 2045 forecast model is going to be a future scenario. So you're going to take your base version and you're going to load that in as your file for comparison. And then you're going to make sure that you select it as the base file. Version is the base file. And then when you click OK, it should load all of the attributes and objects from that old file from the base file into your current 2045 future project. Thank you. Sorry about that, everybody. All right, so the last question was, can we go back a couple steps and show how to run the import again, or the model comparison? So what I'm going to do is I'm going to kind of go through that process again. So we opened up our 2045 model. So we've opened up our 2045 forecast model. And then you're going to go into the File menu, go to Compare and Transfer Networks. And then once you have your Compare and Transfer Networks up, you're going to select Compare Current Network with a Version File. And then again, just like we said before, select your base model year, click Open, make sure it says Version File is base, and then you can click OK. This should take a minute or two to, basically what it's doing is it's taking all of the objects that were in the base and it's reading in their attribute values and their geometries. And it's comparing those ID numbers that are on the base volume or the base year to the new year, to the forecast year. And so what it's doing is it's identifying any changes that were made, any new additions, any deletions that were done, any changes to the attribute values, anything like that. And so now what you should get after doing that process is you should get this comparison summary here. And so this is a model transfer file summary. You can see for example, if I click on nodes, if I expand the nodes option, you can see that there were 21 new objects that were inserted into this new build. And you can actually expand out and see what those objects are. If you have this side by side with your network editor window, you can actually click on the object and it will show you where that object was created and what is it doing. So for example, I can look at links and we can say, okay, we inserted 70 new links. So I can click on a particular link and say, okay, this is a brand new link that wasn't in my base model year. In addition to that, you can see that there were this many objects modified. Now, the reason there are so many links that are modified, I would not recommend with 41,000 of them clicking the plus button. That might I'm worried that my computer might die on me again. But there, right there, what this tells us is that there were 41,000 objects that were updated. Now, since we reran the assignment, all of the assigned volumes are going to be different and things like that. So it doesn't necessarily mean that we've changed the number of lanes on 41,000 links. It just means that pretty much every link in the network, if we look at how many links are in the network, there are 41,500 of them. So that means that there's about all but 100 links changed their attributes in some way. So this model comparison really allows you, especially if you're on the reviewer side, to be able to go through and see, okay, what kind of matrices were added and removed. So here we lost 3 matrices, 3 of them were deleted, number 88, 89, and 90. From a trip generation perspective, how many objects were added, deleted, and modified. And so this really allows you to not have to do any guesswork and kind of, you don't have to get into the project and know where everything was in the base model. It'll tell you where everything was in the base model. Were there any new user-defined attributes? In this case, there was a new user-defined attribute. So once we have these model comparisons imported into each other, what we can do now is we can go back and we can look at the attribute values for those objects. So for example, if I double click on a link, where did my link go? Uh-oh, please don't do this again. Sorry, it's been a long day for my computer. There we go. We can look at this link and we can see what values have been assigned to it and things like that. But and those attribute values are assigned graphically. So for example, if I reload that initial start graphic parameter file, if I try to load this graphic parameter file, I can read it in and click OK. And so we can, again, this is just loading the link bars and things like that we saw at the beginning of the session. That's okay. So here we have all the link bars. Well, these link bars, what they're doing is they're displaying the assigned volume for the current assignment. But what we can do is we can utilize these link bars to show different things in addition to just this forecast year's assignment. Since all of the attributes are imported from the base year, the forecast year, and then the delta between the two, we can utilize those attributes to show differences in trends or assignments. So in this particular example, we could look, I believe this is in the Pensacola area, you can see that we can display link bars in such a way that they will show where trips were decreased, total number of trips decreased, and where total number of daily trips increased. And so you can see larger trends in addition to just the raw assignment results. So I'm gonna walk us through how we can configure our graphic parameter file to do just that. So the first thing I want to do is I want to open up our links list. So I right click and I say list, I right click on links and I say list links. And this will open up a list of all of the links in the network, and it'll show various attributes about this link list. But we don't need all these attributes right now, so I want to show just a few key attributes. So what I'm going to do is I'm going to click this little button next to where it says list layout. I'm going to click this little screwdriver tool. And I want to remove all of the attribute values that I don't really need for the purposes of this demonstration. So in this case, I'm going to select a lot of attributes. I'm going to select everything basically below capacity, and I'm going to turn it off. So I'm going to select everything after capacity, and I'm going to click the little arrow button, and I'm going to remove those. So when I click OK, the only things showing are from node, to node, type number, link length, number of lanes, and capacity. From there, we can find the volume that was assigned to the current link. So I'm going to type in VOL up at the top. I can search volume PRT for this network, and I can add it for this network, or I can add it from all comparisons. So if I click, you see we have this extra button now with the little scales. If I click the scales, what it will do is it will automatically add it from the current year, which is the 2045 forecast year. We have the base 2015 model, and then we have a version comparison. So let's see what this looks like. This should be the delta between the two. So if I click OK, oh no, sorry, it loaded the second one in twice. So in this case, we also want to load in the comparison between the two. So I can actually just remove that one. And what I'm going to do is I'm going to again find my volume. And again, what I did was I selected this network and I clicked the little scales to add these two options. And then I can go into the base year. So here's our base 2015 year. And what I can do is I can say, okay, I want to compare these. So I can do this network's results minus the network results from 2015. I can do 2015 minus this network, or I can do a percentage change, right? So in this case, I can do the raw change, or I can do a percentage change. So what we can see is for a given link, here's the current volume, here's the old volume, here's the amount of change, and then here's the percentage change. So again, to do this, we go into the link list, links, and then we selected this little screwdriver button, and then we just searched for volume, and we looked for the volume for the private transportation, and we added these 4 attributes. So we added by clicking this network and then selecting the scales, it will add in the first 2. And then you can use this scales option, expand that out, and find this value, and this value. So now you can do some comparative analysis between this. If you like this layout, for example, we can hit the save button, and this will save an attribute value. Where's the list layout? You can just type in here, and you can type in, and you can say version comparison. Hit enter, and that should save it as an ability to, it should save the layout of the link list as a .llax file. All right, now we can take this a step further, and instead of showing the volume PRT, maybe what we do is we want to show where the volumes have changed. So I'm going to zoom in on the Pensacola region a little bit. And now what I'm going to do is I'm going to right click on links, and instead of saying list, I'm going to open up the graphic parameters, and I'm going to select bars. So again, right click on your links, graphic parameters, and click bars. What this will do is this will open up your graphic parameter settings for your link bars. So what we can see is we have 3 bars that are currently active, and we knew that because we have our legend right here that says the width is based on the volume, the color is based on the V over C ratio, and then we have some flow bundle outputs for some public transit and some private transportation. And here we can see those same 3 bars listed up above. So what we can do is we can turn off these bars by clicking the X value. This doesn't delete them, it just turns them off. And then we can hit the little plus button. So again, to get to this window, if you're a little bit behind, you can right click on links, graphic parameters, and go to bars. And then we will turn off the existing bars, and we're going to add a new bar to the end. So we see now we have this fourth bar at the end. Now, when we add this fourth bar, what you'll notice is that it has an attribute that we can assign to it. And by default, it picks up the assigned volume. And at the bottom, we see we have these two colors, red and green. So Visum, this is just a default setup. If you click the colors at the bottom where they're red and green, you'll see that the setup says that it's green if it's less than or equal to 0, and it's red if it's greater than 0. So this is kind of a default bar setup that's looking at differences between, or looking at whether there was growth or negative growth. So in this case, the only thing we need to do is we need to switch from the currently assigned volume. So I'm going to click where it says volume PRT, the vehicle AP here. I'm going to switch this attribute value from looking at the assigned volume of the 2045 model. And I'm going to pick out, instead of this network, I'm going to go to where it says the base year 2015, expand that, and I'm going to look at the difference between the two. So I can do the raw difference or a percentage difference. So here we can say this network minus the 2015 model year. So what this will do is this will take this network or the 2045's assigned volume and subtract away the base year 2015's volume. So if I do that and I click the preview button, you can see how the link bars are now assigned based on whether there was added trips or removed trips. So again, to kind of go through this process one more time, right click on links, graphic parameters, you go to bars, you turn off the existing bars, add a new one, and then all you really have to do here is change the attribute from the volume of just the 2045 model to the volume of the 2045 model minus the volume of the 2015 model, and you click OK. And then you can click OK out of this, and now you've created a new graphic overlay for your Visum file. So this allows you to quickly spot check wherever you had growth, wherever you had lost trips, things like that. If you like this graphic overlay, you can go up to File, Save File As, and you can go to Graphic Parameters. So File, Save File As, Graphic Parameters, and then maybe we call this 2045 underscore, I'm going to call it version comparison .gpa. So by saving this model as is, if we were to open up some other graphic parameter files, so for example, here we have my 2045, but let's say we open up the original graphic parameter file. This is just a demonstration here, real quick. So we'll open up all the 2045 link bars and things like that. But since we saved this graphic parameter file already, we don't have to go back through and reconfigure everything. We can just take this GPA file and just drop it onto Visum, and it will reassign all of those graphic parameters to the network. So these graphic parameter files, they're pretty flexible because they're not tied to a specific model. We can use these graphic parameter files on any version file that we have. The only trick with this specific one is it's looking at comparison results. So if you don't have a model that it's comparing to, then you might get some warnings. But in general, the graphic parameter file they're pretty flexible, and you can move them between projects. So if you're working on multiple Visum projects and you have certain layouts that you really like, whether they are list layouts or graphic parameter settings, you can save those as external files like GPA files or .llax files. Here we have our version comparison .llax. You can load those up and they will save your user interface overlays. All right, and then we kind of talked about this already, but with the version comparisons, we'll see this again tomorrow when we do our alternative builds. But you can see what objects were added, what objects were removed, and then you can link them to the larger network. Okay. Sorry, there's a little bit of a trip up at the end with the whole models setup and my computer going down. But now we've kind of reached the end of session 1, talking about file structure, the overview of the interface, what goes into a model, what comes out of a model, and then how to manage scenarios. So I wanted to open it up for any last minute Q&A that we had, any last things that I needed to go over in greater detail. So Johnson, was there anything else that came through chat or anything like that?
Yes. Can you hear me? I think I'll need to double check.
I can hear you.
After this technical difficulties, I feel like I need to double check. Okay. So 2 main things, I guess. First, I think a couple of people asked, about this question. A couple of people asked this question, I guess. I mean, in different ways, but at the end, it's the same question. I think, that Alejandro's question summarizes that really well. So I'm going to read out his question. His question was do you have a cheat sheet to familiarize with the Visum terminology such as V0, PRT, DSAG, whatever? Do we happen to have a cheat sheet, or do we have a sort of a dictionary or whatever we want to call it?
In terms of those specific parameters, the difference, you'll see something like V0 or T0 or something like that. Those are all representing the unassigned expected values. So like V0 is the expected speed and stuff like that. And then you'll see V cur or T cur. Those are the assigned values. So with specific reference to not incurred, that's kind of just a nomenclature. I don't know.
And also, if you move your mouse cursor a little bit up, on top of that V0 PRT, so it typically shows you that tooltips with the definition. So I think we could have a separate cheat sheet as well. That's a great idea. Thanks for the suggestion. We definitely will take it. But for the most part,
also jump into the help. Let me pop open the help and see if that will.
Yeah, but for the most part, if you see any of those weird jargons or terminologies, a lot of times if you move your mouse cursor onto the top of that, it will show you that tooltips and with the descriptions and all that. For the most part, it's our team did a pretty good job on showing that and adding that portion. But still, I think that it's a good idea to have that cheat sheet at the end.
Yeah, for sure. That could be something that we add to perhaps our technical resource hub.
Right.
Yeah.
Okay. And then Chayton, I think this will end up being more of a question for you. So this is a question from Cesar saying, in Cube, future ear networks may have different projects and hence different A/B nodes for those links. And the difference of the links will create gap in the display or the funny value. Could this happen here as well?
Yeah, so in case of Visum, when let's say you have 2 networks and you're comparing those networks, wherever the IDs match, the network difference will be shown as expected. However, in cases where certain network links don't exist in let's say a base case and do exist in a forecast, those volumes would basically be shown as the volumes on the forecast. And of course, the difference over there is just going to be the assigned flow in the forecast -0. And in cases where IDs are inconsistent, yes, you may have the same sort of issue where no value is found for populating the, let's say, the AB node is connected by a link and such properly. So yes, that possibility exists in Visum too. It's just that we handle it a little differently, that instead of putting funny characters on it, we basically just show the value from a network. For example, only the forecast network.
Yeah. But
And
like,
Jen,
but software, good.
yeah, go ahead.
But software itself will not arbitrarily change the numbers or what because you copied over to another one or what, but it's going to maintain that consistency to a certain extent, right?
Yeah. And in this case, for example, the one extra attribute that Visum has on the links is just link ID itself. What we did in this network when we were preparing these networks as cube import networks was, first we imported the network and the AB node IDs were known. And then we took the AB or the link IDs that corresponded to the base network links, and then also renumbered the forecast year network links the same as the AB nodes for the base case. So we harmonized those link IDs in this situation. And there are link IDs still that are in excess of the base case over here, which obviously are the build out links that likely don't exist in the base case.
So there's a follow-up question to that. So when we add in new links, does it affect the from node and to node of the existing links?
No. When you add new links, it will not affect the from node or to node of existing links, except that they may make it, a certain intersection. Something might just be, let's say, a 3-leg intersection. You add another link to add a stub link for a driveway, then you will have another new link in there with the one node being the new node and the other one plugged into the intersection. So it's not there. It doesn't modify ID values arbitrarily.
So we're not gonna expect to see any sudden node number changes because we added a node or link somewhere else. So it only will change numbers or what if you made changes to that particular thing or another object that is related or connected to that particular object, right?
That's right.
Okay, that's cool. And we have a couple of more things. Yeah, it's going up, so it's like I'm getting old, I guess. I cannot catch up. To follow those, that's fine. Levi, you've mentioned about GPA and LLAX file. What are the main differences in between those two?
So the GPA file has to do with the graphic parameter settings. So anything in this menu in the graphic parameters is saved in the GPA file. And anything in the LLAX saves what columns are displayed in your lists. So this isn't necessarily have anything to do with the graphic parameter settings of your network editor. So the GPA file kind of affects your network editor, and then the LLAX affects your lists, kind of is the way to think about it.
Yeah, you can think of the GPA file more as a map template if you're used to that terminology. And that's what the GPA file is. It's basically a map template.
All right. So another question that I have here is in Cube, when you add a link or node, you can specify a node number that it can start from. Is this the same case in Visum?
Yep, that's correct. So over here in Visum, if let's say you're building out the network, you can modify the node and link or give it a node and link ID as you like. We also have some renumbering routines built in. So let's say you want to pick new ranges for node numbers and such. It's also possible to renumber after the fact as well.
Okay, so let me go back up. And here's one more thing, where, he's asking, when he opened up the model for 2045 forecast year model, he couldn't see the volume capacity ratio on link bars as we have in the 2015 model. Can you please show us how that could be added?
So the way it was displayed in the 2015 year was the volume to capacity ratio was displayed as a color on the link bars. And so you can specify the filling based on down at the bottom of the link bar, you click the filling option and you can set thresholds.
So Levi, this would be a good demonstration of how to use a GPA file.
Yeah.
So perhaps you can save the GPA file from 2015 and load it into 2045 to demonstrate that.
Yep. Let me do that. So I got to open up my 2015 model real quick.
And like while we're loading it, Chetan, can you say something about there was a question whether we're using turn penalty file or not. Can you answer? I think we got this question sometime back. Can you elaborate on that once again?
Yeah, sure. So in Visum, the turn penalties are specified in two ways. You might be familiar with the two ways. One is you can either completely block the turn, and then the other one is you can have a turn penalty or base delay applied to a turn. So this is typically done either by a formula calculation. If you were modeling turn dependent or volume dependent turn delays, since Visum applies volume delay functions to turns as well, if the modeler desires. So in this case, how we do it is basically we specify the numbers in a list form in the turns, or we set an attribute that allows the user to essentially load those penalties. So over here, you can see that T0 PRT field, that's a base delay for the turn. So that's where one would enter the penalty for the turn. And if you had to block the turn completely, you can select those tsys set and then remove those tsys set. And that basically means that the turn is blocked or close to any kind of routing. And this can be changed based on the transport system or the mode that traverses the turning movement. So you can block it for trucks and keep it open for cars and so forth.
Okay. So with regard to that volume capacity ratio, so here's our 2015 model that we have, and it has these graphic parameter settings. So we can just go to File, Save File As, Graphic Parameters. And I'm going to put it in my graphics folder just to be consistent. And I can say 2015 settings. And we should have that file now in the documents folder. Training. There we go. All right, so if I come into my documents folder, we should have this 2015 settings GPA. So I can just open up the 2045 model and drag and drop it. And it should populate with the link bars in addition to the, what am I trying to say? In addition to the volume capacity ratio as well. But to get to this point, in the link bar settings, again, it's just you have a bar that's, in this case, scaled based on the volume, but the fill color is based on the volume to capacity ratio right here, which is just a calculation. And then we just set thresholds for what the different colors mean. So you can use like a black gradient, you can use a red-green gradient. It just depends on how you want to display those colors.
All right, I think that was the last question that I could find, and there are a couple of more questions that I probably will get back, via email or message. So I think thank you all for joining today's session. I mean, and again, we apologize about some technical difficulties that we had, but we'll try to make sure that it will not be the case next time. So again, we're going to see you again tomorrow at 1 p.m. at the same time using the same link. And then we're going to go over a couple of more sections, a couple of more stuff that we didn't cover today as well. So thank you, and I guess have a great evening.